Hi guys, this is Mrs. Rooker. This is the video for 3.2a. I'm going to have you guys pause the video right now and work on these review questions, and then I will do those with you guys when you unpause the video. Okay, so to find the inverse, you need to switch x and y. So this will be x equals natural log of y plus 4. And then we need to solve for y. We can't really solve this as it is right now, or we can't really get y by itself right now until we take care of the log. So what I'm going to do is I'm going to exponentiate both sides. What that means is I'm going to make this an e to the x power, and this is going to be an e to the ln power. So I'm exponentiating both sides. I'm turning them into an exponential equation. What the reason for that is it's going to cancel out the natural log, and all I'll be left with on this right side is y plus 4, and all that's left on the left is e to the x power. Now y is almost by itself. The last thing I need to do is subtract the 4. So y is going to equal e to the x power minus 4. That's your answer for number 1. Number 2, the domain of y equals 2 to the x power. So you need to know what shape this graph looks like. It's an exponential function, so it'll look like this. Domain is how far left and right it goes. It goes forever to the left, and it goes forever to the right. So it is all real numbers, or you could write this as a negative infinity to positive infinity. And then the range is how high up and down it goes. Exponential growth functions have an asymptote at 0 if there are no shifts. So it never goes below 0 and it never touches 0. So your range is going to be y is greater than 0. This could also be written as 0 to infinity with a parenthesis, not a bracket. If the multiplicity of a 0 is 5, then the graph will blank the x-axis. So this is asking if your function will touch the axis and then come back up, or if it will actually go through. And if the multiplicity is odd, 5 is an odd number, then it will cross through the x-axis like this second one here, like this one did. Okay, so it's not like that one. Okay, so today we are going to be graphing exponential functions and log functions. So we're just going to kind of write down some information about exponentials first and then logs second, because exponentials and logs are inverses of each other. So all of their information should be basically flipped. So the domain of an exponential function. Exponential was like my example up here. That's an example of exponential growth. The domain is always going to be all real numbers. And then the range is going to be more restricted. I'm just going to do the range of the parent function. So this is a parent function here. There's no shifts. So the range would be x is greater than 0. Sorry, not x. Y is greater than 0, because we're talking range. Y is greater than 0. The base must be positive. And then the input is the x value. Basically, when we're plugging in a number, we're plugging in for x, and we'll get an answer out for y. With exponentials, we always have horizontal asymptotes. So that's the horizontal line that the graph approaches but does not touch. And the horizontal asymptote is always going to be located at it's y. Y equals whatever your k value is. So that should be the number on the very end. Now everything's flipped for logs. So for logs, you don't have a domain of all real numbers. you have a domain of x is greater than 0. So logs will look something like this. Instead of having a horizontal asymptote, we're going to have a vertical asymptote. And it will look something like this. It's going to go along the asymptote and look something like that. So the domain is x has to be greater than 0. You can see here that this is on the right side of the axis. So x is always greater than 0. It's not going on the left side of the axis. The range is going to be all real numbers. Oops. Which could also be written as negative infinity to positive infinity. This could be written as from 0 to infinity. All right, the base must be positive. Now this time the output is the x value, not the input. So what that means is we're actually plugging in for y and getting an answer out for x. So it's just backward. And then we have a vertical asymptote at x equals h, whatever your h value is. Now we're going to practice graphing. We are going to graph an exponential and a log on this first one so that we can compare the two. So this first one is exponential. It's going to have a horizontal asymptote at 0. So this is the line y equals 0, the horizontal asymptote. And then I'm going to pick just two crucial points that I'm going to graph. I'm going to plug in two numbers. So the first number I'm going to plug in is 0. So I'm going to plug in for x, I'm going to plug in 0, and I'm going to plug in 1. When I plug in 0, 2 to the 0 power is just 1. Anything to the 0 power is 1. Then I plug in 1, 2 to the first power is 2. So I've got the point 0, 1, and 1, 2. I can always plug in more points if I want to. I could plug in, let's say I plug in 2. 2 to the second power is 4. So that'll give me the point 2, 4. And I could keep going if I want to, but that's enough points for me. And then I just sketch the graph and make sure my arrow doesn't cross the asymptote. It's never going to cross the horizontal asymptote. So the domain of this, because it goes forever left and forever right, is negative infinity to positive infinity. You also could write that as all real numbers. And then the range is how high up and down it goes. It never goes below 0. And it never actually touches 0. So that's why I put a parenthesis and not a bracket. And then it goes up forever. So it goes up to infinity. All right, now I'm going to switch colors and graph the log. How I am going to do this is I am going to convert this to exponential form. So g of x is like y equals log base 2 of x. And I'm going to convert to exponential form and just plug in the way I did on the other one. So to convert to exponential, I do a loop-de-loop method. So I start with whatever the base is. So the base is 2. And that's going to be my base of my exponent. Then I loop to the other side of the equal sign. So 2 to the y power. Then I loop back to the other side. 2 to the y power equals x. All right, and that's what I'm going to plug into to graph. X, y. Now, like I had mentioned up here, our output is going to be x, not our input. So what that means is I'm going to have to plug in values for y and get an answer out for x. So I'm going to plug in 0, 1, and maybe even 2 for y and get an answer out for x. So when I plug 0 in here, 2 to the 0 power is 1. Then I plug 1 in here, 2 to the first power is 2. Then I plug 2 in here. 2 to the second power is 4. So you might notice that these points are the same as these points, just flip-flopped, which is because they are inverses of each other. So I'm going to graph these points. 1, 0, 2, 1, and 4, 2. One thing I forgot to mention is you're going to have a vertical asymptote whenever you have logs. So it's a vertical asymptote, not a horizontal asymptote. And now I just sketch along the asymptote. And because these are inverses of each other, they should be symmetric over the line y equals x. If I were to reflect this red line, the red exponential growth over the line y equals x, it'll give me the log function. All right, moving on to the next one. I only have to graph a log. I don't need to do an exponential on this. The way I do this is I convert this, I convert that to exponential form, and then I deal with the shifts later. So that 1 on the end is a shift. I'm going to deal with that after I've done everything else. So I ignore the shift at first, and I convert this to exponential form. So that's a y. I'm going to do the loop-de-loop method. So it's going to be, the base is 3. Then I loop to the y, so 3 to the y power equals x. And then I'm going to find these crucial points. Remember, for logs, I plug in for the y. So I'm going to plug in 0 and 1. I could plug in 2 also if I want. When I plug in 0, anything to the 0 power is 1. Sorry, my pen froze. There we go. And then plug in 1, anything to the first power is itself. So that's just going to be 3 still. And then I would graph those points. 1, 0, and 3, 1. Okay. I am almost done. The last thing I need to do is think about what my shift is. This 1 on the end says I'm moving everything up 1. So each point goes up by 1. So I'm no longer looking at the red points, I'm looking at the blue points. The asymptote didn't have to move at all. It's still at 0. And I just sketch my curve based on my blue points after I had shifted everything up 1. The domain is how far left and right it goes. It never goes past the asymptote, so it goes from 0 to infinity. And then the range is forever down and forever up, so that's negative infinity to positive infinity. Or all real numbers, because it goes forever up and forever down. So moving on to the next one, we're going to do the same process. We are going to graph this in exponential form, and then we're going to deal with the negative in front. A negative in the very front reflects over the x-axis. So what we're going to do is we're going to take all of our points and flip them over the x-axis after we found what they are going to be by converting into exponential form. So I am going to ignore the negative at first and convert this into exponential form. So this is going to be, we always start with the base, 4 to the y power equals x. Okay. I'm going to plug in values for y and get answers out for x. So I'm going to plug in 0. Anything to the 0 power is 1. Plug in 1. Anything to the first power is itself. I could plug in 2, but then 4 squared is going to be 16, which is going to be way off my graph, so I don't even worry about that. I'm going to graph those points. So we have the point 1, 0 and 4, 1. But I need to reflect everything. Sorry, my pen froze. There we go. I need to reflect everything over the x-axis because there's a negative in the very front, which means this point stays where it was because it was just on the x-axis. This one is going to be reflected over, instead of being 4, 1, it's now going to be 4, negative 1. The asymptote is still a vertical asymptote at 0, at x equals 0. And then I'm going to sketch, my curve is going to always start kind of along the asymptote and then curve upward, or flatten out that way. So it should look kind of similar to example number 2, but it's reflected over the x-axis. So the next one, I am going to ignore these shifts at first, convert to exponential form, and then deal with the shifts. So the base is 5. It's going to be 5 to the y power equals x. Plug in some points. For y, I plug in 0 and 1. When I plug in 0, anything to the 0 power is 1. And plug in 1, I get 5. I'm going to plot those points, 1, 0, and 5, 1, but then I'm going to shift them. So let's look at these shifts. This plus 1, remember it's always opposite, is going to be left 1. Whoa, bad handwriting, sorry. Left 1. And then the negative 2 on the end means down 2. So left 1, down 2 for each of these points. Left 1, down 2. Left 1, down 2. Since there was a left shift, the asymptote is no longer at 0. The asymptote has shifted to the left as well. So any left or right shift affects the asymptote. And then it's just going to be a curve like this. Sorry, bad handwriting. And that'll be your graph. I forgot to write the domain on these, sorry. The domain on this one is how far left and right it goes. It never crosses this asymptote, so the domain is 0 to infinity, or x is greater than 0. On this one, the domain shifts a little bit. The next one, it's now over at negative 1 to infinity, or x is greater than negative 1. Couple more, let's see, 4 more. So this one has a couple interesting things going on. There is no base written, which means we automatically assume that the base is 10. So I'm going to convert to exponential form first. It's going to be 10 to the y power equals x. We're ignoring the negative and the shift on the end for now. We'll deal with that in a little bit. So it's going to be 10 to the y power equals x when I convert to exponential form. Figure out a few points, x and y. I'm always going to plug in for my y when I'm doing logs, so I'm plugging in 0 and 1. Anything to the 0 power is 1. Anything to the first power is itself. So 10 to the first power is just 10. I am going to graph those points, and then I'm going to do the reflection and the shift. So I'm going to graph 1, 0, and 10, 1, which is off my graph, 7, 8, 9, 10, 1. So it's somewhere over here. But then I'm going to take those and I'm going to reflect over the y-axis. That's what this negative does here. So it reflects over the y-axis. So instead of being over here on the right side, I'm going to reflect it over to the left. So it's going to be here, and this point's going to be over at -10, 1. And then I need to shift everything up 3. So up 1, 2, 3. Up 1, 2, 3. The asymptote didn't move at all because I didn't shift left or right at all. So the asymptote's still at 0. And these are my points. And then the domain on this one, since it goes forever to the left, it goes all the way to -infinity, but it never goes past 0 to the right, which is the same as x is less than 0. Okay, next one. Same base. Since it's not written, we have a base of 10. We're going to ignore the 1/3 and ignore the -1 as we convert to exponential form, and then we'll deal with those later. So this will be 10 to the y power equals x and y. Plug in 0, plug in 1. We might need to plug in some more things on this one, but for now we'll just do 0 and 1. 10 to the 0 power, 10 to the 0 power is 1. 10 to the first power is 10. And then we're going to graph those points. 1, 0. And 10, 1. It's a little off the graph. And then we are going to do a vertical shrinkage. So it's going to be 1/3 as steep as it normally would. This one's going to be really shrunk, and it's going to be 1/3 as steep. This number here, this point here doesn't need to change, but the one out here at 10, 1 needs to now be 10 and then 1/3. So it's really, really shallow. The other thing that has to happen is we need to shift this to the right 1. So everything goes to the right 1. Including the asymptote. The asymptote is now at +1. And it's just going to be really, really shallow. Really shallow. The domain is x is greater than 1, or from 1 to infinity. All right, the last two involve natural log. So we are going to compare an exponential again to natural log. Natural log and e are inverses of each other. So for e, we need to remember what e is equal to. And e is equal to about 2.72. So when we're doing exponentials again, e is an exponential. You just plug in for x and get an answer out for y. So I'm going to plug in 0, 1, and 2. When I plug in 0, anything to the 0 power is 1. Plug in 1, anything to the first power is itself. So e to the first power is going to be 2.72, about 2.72. And then plug in 2. E squared is going to be about 7.4-ish. I'm going to graph those, 0, 1, 1, 2.72-ish, and 2, 7.4. So looks like this. The asymptote is a horizontal asymptote at 0, y equals 0. All right, natural log of x should be the inverse of that, so it's going to be everything just like that, but flipped. To do this, I'm going to convert to exponential form. So natural log of x means log base e of x. We don't usually write it like that, but that's what it means. I'm going to convert this to exponential form just like I did on all the others. I'm going to do e to the y power. I'm going to do this in red. E to the y power equals x. And now I'm plugging in for y and getting an answer out for x this time. So when I plug in for y, e to the 0 power is 1. E to the first power is 2.72. And e to the second power is 7.4-ish. Now I graph those, 1, 0, 2.721 is about there, and 7.42. The asymptote should now be a vertical asymptote at x equals 0, and my curve goes along that asymptote, looks like that, which should be a reflection over the line y equals x from the other graph. The domain of the red graph, the natural log of x, is going to be x. My pen would work, there we go. X is greater than 0 because it goes to the right of 0. The domain of the other graph, the blue graph, would have been all real numbers because it goes forever left and forever right, because it doesn't have a vertical asymptote for the exponential one. All right, the last one, we're almost done. We are going to graph this the same way we did, I'm going to highlight it. My pen would work, there we go. We're going to graph it the same way we did this one over here, because we're just going to do natural log. We are going to ignore the shifts at first, and it's going to look essentially just like this, because we're going to do, sorry, I'm having some technical difficulties. Okay, so this is, natural log is log base e. We do e to the y power equals x, which is the same thing I had down here. So I'm going to end up with the same points. X, y, I get 1, 0. When I plug in 1, I get 2.72. When I plug in 2, I get 7.4-ish. I graph those, 1, 0, 2.72, 1, and 7.4, 2. But then I need to make sure to shift them. This is going to be left 2 and then down 2, because it's opposite of this one. So left 2, down 2. So I just take each point, left 2, down 2. Left 2, down 2. Left 2, down 2. The other thing that moves left 2 is the asymptote. So the asymptote is now at x equals -2. And that's my graph. The domain is going to be x is greater than -2 because the asymptote was shifted over to -2. So to recap, because I think that was it for this video. When you graph, you are going to convert everything into exponential form, but you are going to ignore the shifts when you do that. Then plot your points, then shift each of those points the appropriate amount that you need to shift. All right, thanks guys.